Good day everyone. I'm Nichole Ann N Balagat from B17 and I would be discussing my project in Electronics 1 Laboratory, the Common Source MOSFET Power Amplifier Circuit. First of all, what is a MOSFET? A metal oxide semiconductor field effect transistor, or also known as the metal oxide silicon transistor, is where the voltage determines the conductivity of the device. It is used for switching or amplifying signals. The ability to change conductivity with the amount of applied voltage can be used for amplifying or switching electronic signals. MOSFETs are now even more common than the bipolar junction transistors in digital and analog circuits. So this is how it looks like. Yeah. So there are four classifications of MOSFET. The N-channel depletion mode, which is right here. The P-channel depletion mode, which is right here. And the N-channel enhancement mode, as well as the P-channel enhancement mode. So what are the difference between the depletion and the enhancement mode? So for the depletion type, it is the transistor that requires the gate source voltage to switch the device off. The depletion mode MOSFET is equivalent to a normally closed switch, while the enhancement mode is a transistor that requires a gate source voltage to switch the device on. The enhancement mode MOSFET is equivalent to a normally open switch. Basically, the difference is that when in depletion, it is off, and when in enhancement, it is on. So now I am going to be showing you my circuit that I have made earlier. So this is my circuit. So I am using a MacBook, so it may look different. The controls may be a little bit different, but these steps are the same. So I have already input the values for the voltages, resistance, the capacitors, etc. And now if I am going to try to run this one, you would see that no analysis command is found because I have not yet input any of the SPICE directives. Also, I have already labeled each and every one of the nodes that I need. So this one is the, sorry, it's running again. There. So this one is the voltage input. This one is the voltage output, the drain, the gain, and the source. So now if I am going to draft a SPICE directive of OP and place it right here. And if I try to run, it would run. Yay. So now I'm going to view the SPICE error log in order for me to see the values of the VG, VD, and VS. So SPICE error log. As we can see, it is all here. So now as for my voltage gain, I have 3.33. For my voltage drain, I have 7.62. And for my voltage source, I have 1.19. So next thing I need to do is to try to find the value of the voltage peak to peak of the V in and the V out, as well as the AV parameters. So in order for me to do that, I need to once again draft a SPICE directive. So first of all, I'm going to type in a transient of 0, 1 and 0. Control mesh or mesh V in peak to peak V in, and then that's the output, and lastly the AV parameter. I'm just going to put this below this one. So once again, for the whole circuit to recognize the changes, I need to run once again. So I'm just going to adjust everything so that we could see both clearly. So now if I am going to plot the voltage of the input, it would look like this. So it's a series of waves like that. So this is correct because this is how it should turn out. And then I am now going to view once again the SPICE error log for me to get the value of the peak-to-peak voltage of input and output. So it is here. There, I'm going to copy and paste it right here for me to be able to compare the values that I have simulated. So for the peak-to-peak value of the input, I have 1.99 milli, or actually 2.00 milli. And for the peak-to-peak voltage of the output, I have 8.29 milli. And then for the AV, I have 4.14. So that concludes my whole presentation. Thank you so much for listening, and I hope you have a great day ahead.